Right. Hey, look at this, guys. We're into March. Yeah. Oh, yeah. I don't really know what to call this. Just we'll just call this more log equations, I guess. Um, as always, you're going to prepare a page of notes. And so you can just go through all the sections of your notes that say log equations and just try to consolidate the main ideas or examples into one place. But it seems like that's kind of all we've been doing now for at least a week is just solving equations with the word log or natural log in there. So I have 4 examples, and then I just whipped up a worksheet, 8-question homework assignment. So I thought that today, after we finish our notes, you can work on finishing up that delta math from Thursday, which I noticed that you've got a long ways to go. And then you can also work on the paper one that I'm going to hand out. And then tomorrow, let's plan to have everything done and we can get headed towards the practice quiz. Practice quiz has 42 questions, I think. Pretty sure. So it's a lot. There's a lot on that plate. So anyhow, these are a very specific little type. I realized as I was going through the practice quiz, because it's from last year, and then I was like, "Ooh, gosh, we didn't talk about these." And I was gonna teach it just as we went, and thought, "No, we should practice this." So I have 4 examples for you here. So this is what these will look like today. And you'll see these when you get to the practice quiz. There'll be a little section, like a row of problems that are all cut from this same cloth here. So we have log base x of 343 equals, well, I hope I didn't do that wrong. Let's see. I think I have that upside down. Let's do it this way. I'm pretty sure I put that upside down on my note card. And it matters. All right, good. Yeah, so anyways, this is a little kind of pocket, a little subgroup of log equations. What do you think we would do first? I know it's been a weekend, but still. Yeah, I mean, that's just what we do, right? If we see a log equation that's like there's no condensing required, no one has to move to the other side, no dividing, whatever, we're just going to hit it with the water cycle. That's really kind of the big idea with what's going to get you through a lot of questions is just cycle it out, convert it out of logarithms, and then let's take a look at what we have. So we're going to have x up to the power of 3/2 equals 343. And under normal circumstances, like you would just be able to look at this, like if it said x squared equals 36, you'd have no issues with just saying, oh, x has to equal 6, right? But a case like this, it's a little bit more difficult to see what number would I have to raise to the 3/2 power to make it equal 343. So here it is. If you listen for 20 seconds, I mean, obviously I'd love it if you listen for the whole time, but if you just focus on 20 seconds, let it be these 20 seconds. Here we go. The way to solve an equation like this is to raise each side to the power that is the reciprocal of the power that you're trying to kill. And we'll talk about why that is here in a second. It's pretty basic, like 7th grade kind of math, but seeing it in this context could be a little bit strange. So as you know, when you have an exponent and you raise it up to another exponent, you multiply those exponents together. So I'm going to draw your attention to this. I won't do this every single time, but in this green box is just a little itty bitty multiplication problem that says 3/2 times 2/3. Those are called inverses or reciprocals, right? And when you multiply them by each other, what happens? Yeah, they essentially cancel, right? You do get 1. I appreciate when you guys say that, but the real upshot is that they just kind of go away because we don't need to put x to the power of 1. So that's the beauty of that step is I can essentially get x by itself in a way that we've probably never really done before. Like we're used to square rooting maybe or dividing by something. But in a case like this, you can actually raise to a reciprocal power, which is pretty cool. So when the 3/2 exponent and the 2/3 exponent cancel each other out, the algebra of it is done. We have x equals and the equation is now solved. But what we need to do to find the answer is do the math on the right-hand side. And it's been a little bit since we've talked about this. So how do we take 343 and raise it to the power of 2/3? I don't know if we've ever done it in this direction before. I've had you go the other way, but maybe not this way. So any thoughts on that? Yeah, I'm glad we're doing this today. The two numbers in the fractional exponent each serve a purpose. Do you by chance somewhere back in that dusty file cabinet of information remember what role the 3 serves the bottom of the fraction? It's been a while. The denominator of the fraction serves another purpose when we go to twist this out and figure out what it equals. It's the radical index. It says make a cube root. That's what his job is. Like I said, it's been a while. You've done this, you've just done it in the other order. I've given you the radical and you've converted it over into exponential. We're just going the other way today so that we can do the math. That's the idea. And then does anyone remember by chance what the 2 does? Right. And I don't, instead of doing it that way, I'm actually, not that you would remember I said this, it was a pretty obscure little sort of parenthetical comment in a lecture, but you don't have to put the square on the inside. And I would advise actually that you not, just because if you square the 343, it gets really, really big. So you can take that exponent. You always have the option to put it as the power of the thing on the inside or an afterthought power on the outside. And we're always, I think, assuming that we're always going to pick the one on the outside, because this keeps us in the land of numbers that we should be able to do with just a notes page or one of those powers cheat sheets or something like that. That's always the goal, is can I avoid, that's like operation stay away from the calculator. Like, I get that sometimes we bail, but now comes the pop quiz. Does anyone remember what the cube root of 343 is? It is. So if I replace this purple portion with 7, the answer is 7 squared, which is 49. So that's your workaround for these, is you water cycle it up, write it as an exponential equation, and then you apply a reciprocal exponent and apply it to both sides. And that's that. All right, let's go again. Let's do log base x of 1 over 36 equals 2/5. So we have 4 examples, and then I do have, like I said, the worksheet has 8 problems on it. So by the time I'm done with you here today, you will have had a chance to practice this process 12 times. Should be plenty, I would think. I hope. So step 1, right? Cycle it up. So we're going to take the x, raise it up to the power of 2/5. And then we're going to set that equal to the argument of the log, which is 1 over 36. We really want to get this method stuck in our head here today. So what's the next step? Yeah, raise both sides. All right, so we're going to raise both sides of the equation to the power of 5/2. Did you say 5/2? Got it? So remember to use the reciprocal power. You don't want to use the same exponent or it won't go away. You want to flip it before you apply it. The 2 exponents on the left just auto kill, boom, boom, and we're left with x equals. And there's just a math problem. What you're going to find with these is really it just boils down at the end to a math problem. A pretty, I think, kind of simple math problem. So the question becomes, how do you deal with this dumpster fire over here? Well, again, you just have to know what everybody's role is. What is the role of the 2? He's a root, right? So he says take a second root of something, and then what is the role of the 5? Yeah, he exponentiates it, but afterwards, right? Again, I think you're crazy to put that exponent inside. You want to put it outside so that you can, again, this is operation dodge the calculator. It's kind of what you should always think is, can I avoid having to use that silly thing? Right, we use it when we have to, though. So then I'm going to stick the argument, not the argument, but the base, the 1/36 inside. And notice I did not put the number 2. I'm going to write it, and then I'm going to erase it. We do not put 2's on second roots. We assume that they're there in the absence of an index. Then we assume it's a 2, right? We always have. So what is the square root of 1 over 36? Nope. I get you guys are piecing some things together there, but don't turn this into something that it's not. What's the square root of 1? What's the square root of 36? Okay, guys, don't turn that into something else. You got some loggy sorts of things in there. And we're not talking logs by this point in the problem. We're just evaluating stuff, getting math answers. And then what is 1/6 raised to the 5th power? It's 1 over a lot. And this would be a good time to use your calculator. So despite efforts to avoid the use of it, 6 to the 5th is not something that most people know. What did you say, Coop? 7,017. So that's what the answer to that problem would be, right? So far, so decent. Okay. Couple more. All right. Next one, we have log base x of 729 equals negative 3/2. And if you're going to cut corners and start skipping steps, please don't volunteer that information right now during this part of class, okay? You save that for yourself. Right now, we're going to follow the steps methodically, faithfully, and eventually, if you want to cut corners, I get it. So we're going to water cycle this up, and we're going to say x to the power of negative 3/2 is equal to 729. And this, we're not in the asking questions phase of the problem yet. We've done literally no math. And even in the next step, we will do no math. We're just following directions. What power are we going to raise both sides to? To the negative 2/3. To kill a negative, you have to use another negative. Be clear? Negatives kill negatives. So you got to reciprocate it, but keep the sign the same because you want either two positives to multiply or two negatives, like get it to become +1. And then our exponents are going to go swoop, swoop, kill each other, and we're left with x equals. And yet again, for the third straight time, there's just a math problem. And so I have to deal with 729 to the power of negative 2/3. Now I'm going to show you how to do this when you have a negative exponent, because it's actually a lot simpler than you might think. But really, the negative exponent, do you guys remember what negative exponents do? That's what they do. They essentially take things and say, if you're an upstairs number, I'm going to move you downstairs. And hey, if you're already a downstairs number, I'm just going to move you back upstairs. Negative exponents are pretty weak in that sense. They don't have a lot of clout or power. So I'm just going to take this 729 and I'm going to move it to the bottom of a fraction with a 1 on the top. And then I'm going to reapply the exponent, but this time I'm going to make it an exponent that is positive. That's the toll that you pay when you take something with a negative exponent and you switch it either up or down. You just simply pay the toll as switching the sign of the exponent to positive. And what happens now is it's the same math problems that we've been doing, except we're doing it in the bottom of a fraction, right? And so here we go. What purpose or role does the 3 on the bottom serve? It's a cube root, right? That's the index of the root that we're going to use. So he says, build a root with me as your index. And then what power does the 2, or what role does the 2 serve? It's your exponent, right? It's your afterthought exponent. Again, I wouldn't stick it inside because you'd have to square 729. And we don't want to do that. So, and then you stick the 729 in, and we, as always, hope that you've got a power table laying around somewhere. What's the cube root of 729? It is. And what is 9 squared? Good. So the answer is 1/81. The moral of that story is you're essentially just doing the same stuff we did in the first two examples. You're just doing it flipped. So far, so good. These can be a little tricky. All right, the fourth example is, if you're paying attention, you probably know exactly where I'm headed with this, but here we go. Log base x of fraction 1/16 is equal to a negative fraction, negative 4/7. So we're going to have some flipsy-do in here. But again, the first step and the second step have absolutely nothing to do with being good at math, quote unquote, good at math. They're just compliance, following directions. So step 1 is to hit it up and cycle it out. So x to the power of negative 4/7 equals 1 over 16. Again, no math at all, just following directions. Step 2. Careful not to say multiply by. Remember, we are raising to the power of -7/4. Very good. And I do know exactly why you would say that we're multiplying by, because it winds up feeling that way. Okay. So the exponents on the left-hand side, the 7s, boop, 4s, boop, negatives, boop. So that's, I mean, like mission accomplished, x equals. So I thought this would be sort of the last question you could have is what happens if it's already a fraction and I apply a negative power to it? What happens? Yes, you just flip it again. I mean, the really negative exponents, once you master them, they have no power over you at all. You understand that a negative exponent doesn't control the answer in the sense that it turns it negative positive. It simply flips things up, down, up, down, up, down. I mean, if you're in the bottom, you go to the top. If you're on the top, you go to the bottom. Negative exponents are weak sauce. So what we're going to do now is we're going to take the 1 over 16 and we're going to flip it over to 16 over 1, also known as just regular 16. And then we're going to raise that now to the power of +7/4. Remember, that's the fee, the toll. You flip it, change the sign. We don't evaluate things with negative exponents. We fix them so they have positive exponents, and then we evaluate them from there. And the same series of questions. What role does the 4 serve? He's the index. He's the flavor of the root. He says, make a root with me as your index. 4th root. And then the 7 is the afterthought power. And then the 16's like, I'll just situate myself right in here. And we do the math. What is the 4th root of 16? It is 2. And what is 2 to the 7th power? Therefore, your answer is 128. So sometimes your answers come out as fractions. Sometimes they don't. It's just, you follow those steps, you can't go wrong. So that'll be it for recording today. What we're going to do after this, again, I'm going to hand out assignment 46, and you're going to spend the hour completing, hopefully finishing assignment 45 on Delta and 46 on paper. Those are the goals. Got it? All right, cool.